brain. This brain can sustain heartbeat, breathing, ultimately, some function, the autonomic nervous system would work, but there'd be no cognition.
It's like an encephalon, right? Like with without brain.
Oh, the anencephaly?
Yeah.
Anencephaly, this never happens.
Yeah.
This development doesn't happen, so that the brain will be developing from the diencephalon down. The whole telencephalon area would be missing. Yeah. So the ventricular system. We have the lateral ventricles here, this weird lateral ventricle. That weird lateral ventricle, okay? So you have two of them. And the reason you have two of them, thinking back to those kind of elephant ears forming on the side of the telencephalon, as that pulls out, it's pulling these with it. They're being pulled out. Part of it moves forward, okay? And that's this. You'll notice right here, here's the neural tube coming up, and then it's right here that this gets pulled to one side, the other one gets pulled the other way. This moves forward slightly, and then the developing telencephalon moves backwards, and then part of it moves forwards. And the lateral ventricles really are defining all of that movement that goes on during development. Then, you remember, the neural tube is going to fold in two spots. We have the folds that are happening right here. So, we have the neural tube, it folds back and back on itself, and that's what's going to give you that funny shape through there. As we continue down now towards the fourth ventricle of the brain is being pulled out as the cerebellum develops and as the pons develop. These are being pulled out, and we have those lateral recesses or lateral apertures forming. So the whole development, the whole adult version of the ventricular system, all of the shapes, all of the weird folds and everything in there, the result of those developmental stages that we looked at earlier. Okay? And if you think about it in those terms, as you're trying to learn all these weird shapes, it starts to make sense. Yeah?
When you're saying all this pulling and stretching, that's just due to like cell division and
That's cell division. That's what. There is no real pulling and stretching.
Yeah.
It's differential cell division. And so the telencephalon, as it forms, is moving. It starts out like this, and then it moves out in this direction. And once it gets into that V, it's then starting to move forward a little bit, to the side, and back. And you end up with the two lateral ventricles that are kind of branching out from the original neural tube. Okay? You should be able to label the ventricles. You should be able to do that. And then we talked about the flow of CSF. So in there, okay, we start at the various choroid plexes. We flow down the cord. We flow out around everything. This shows it better. And what I like about this is that it's showing you that you have all of this choroid plexal material. Each of the ventricles, so the two lateral ventricles, the third ventricle, and the fourth ventricle, all have choroid plexus. Okay? That's where you are essentially generating CSF. The CSF from the lateral ventricles has no place else to go. So it moves through the aqueduct to the third ventricle, or it joins in with the CSF that's being produced there. That has no place to go. It comes down the aqueduct here, and is going to join into what you're producing in the fourth ventricle. Fourth ventricle has 3 apertures, 2 laterals, 1 medial. That's where the CSF gets out and surrounds the whole central nervous system. All of that ends up in the meningeal system. This is a really nice figure, by the way. It really, and once again, when I point out figures to you, remember, a lot of times there's a little bit of text surrounding the figures, and it really helps to tie that together. So, we have CSF in here, okay? Yes?
So the lateral and medial apertures that you were referring to, were you talking about like the foramen Maggini and like the foramen oblongata?
Yeah.
Okay.
Yeah, they are called,
Just
there
making
are a lot of
these
different,
names.
there are a lot of different names for those, okay? You're seeing them here as the foramen of Mengele here,
Yeah.
and the 2 lateral recesses.
Yeah.
Those, you know.
But I'm just making sure.
No,
that
that's
there's
fine.
more for me
No,
to
no,
know
excellent.
Those things. Okay.
No, I think other people may have wanted that answered as well. But the whole point here is that, as with everything in the brain, almost everything, there are multiple names. And it just depends. I learned them as apertures, and I can't erase that. It is just, it's ironed into my forehead. So, okay? All right. So you're going to be producing cerebrospinal fluid. Protection. It gives you a layer around everything in an enclosed space, a layer of fluid. Fluid's not compressible. As a result, in theory, you shouldn't be bouncing your central nervous system and all of your tracts and pathways against anything. It provides some buoyancy. It holds your brain in place. Without it, your brain could settle down, and you know, you'd have a bigger opening up here, and it'd be squished down there, and you'd be really ugly. Oxygen and nutrients. There's a lot of oxygen in CSF. Remember, you generate CSF from arterial blood. Okay. Chemical signals. There's a minimal amount of chemical signaling going on here. You produce a lot of it. There's a lot of CSF, much more than you need. This whole system only needs about 30 to 40 mils within the ventricular system. The other CSF is in the surrounding spaces, and it is continuously being recycled at a fairly rapid rate. We talked about the capillaries. We talked about the blood-brain barrier and the CSF barrier. These are both important to understand because that's what is going to be involved with controlling how you have access to certain chemicals and molecules. You don't have access to others within your brain. So we're going to be coming back to that in a few minutes. The circumventricular organs. All of these, the red areas here, are essentially peripheral to your ventricular system. All of them are. All right? Vasculosum, the median eminence, neural hypophysis, the pineal, subcommissural, the area postrema. These are all peripheral to the ventricular system, and they have various functions. This is right out of the text, okay? There is literally 2 paragraphs very close to that figure. I just pulled it out. These slides, by the way, are I've just taken these from the earlier lectures. What I will do later on is put up the review slides as well for you if you want that. Okay? So once again, you should know the organization, we haven't even gotten to that yet, the organization of the meninges, the structures, the venous sinus system, disorders and headaches. We'll work our way through that. This is something you should be able to label. You should know where these structures are. All right? This is all critically important. You understand brain bleeds by knowing how this is organized. When we talk about something that is epidural or subdural or subarachnoid, you understand where it all is. Okay? We then took some time to talk about meningitis. Meningitis is an important issue. Like I said, every year or two, I'll have a student that has viral meningitis. I'll get a note, an email that says, well, a student in your anatomy class, blah, blah, blah. Or many times they'll just say, a student of yours anonymously has viral meningitis. Which class? If you're in a class with a student that has meningitis, you should also receive an email, just to let you know. Okay? So, we talked about, fungal meningitis just because last year or 2 years ago it was really in the news. We looked at meningitis, all right? We transitioned to looking at headaches. Oh, headaches. Vascular headaches, tension, hypertension, intracranial pressure, yeah. And intracranial pressure can be due to masses or bleeding. So please just review headaches. And then we looked at this. I still am willing to bet that if I said to you, draw out for me the flow of fluids in your brain, most of you could not reproduce this or understand what's going on. I could be totally wrong. But my experience is it takes multiple exposures to this to really grab hold of what's happening. This side is just the blood flow to the brain. Okay? This is very similar to what goes on in every tissue in your body. Blood comes versus capillaries, arterial capillaries, goes into the interstitial spaces, not the blood, the fluids, goes into the interstitial spaces, comes out of the interstitial spaces at the venous end of a capillary. So this, in a perfect world, would be tied together as a capillary head. Does that make sense? Are we okay with that? That's kind of basic to all tissues. What's really weird and bizarre about your brain is this. This is the CSF production. We have the choroid epithelium here. We've got the blood CSF barrier. Please remember to review that. And we're going to produce cerebral spinal fluid, which is going to pass through the ependymal cells, get to the interstitial spaces once again. Those ependymal cells are located on the surface of the choroid epithelium in the ventricles. Okay? Once you're in so this can be taking place in the ventricular system or as a result of any spaces that have CSF in them. The CSF, some of that fluid is going to pass into the interstitial spaces, get to cells. This is your kind of turbocharging the brain. You're taking extra nutrient, you're taking extra oxygen, you're taking extra chemical precursors so that all of your brain cells, whether they are neurons or glial cells, have what they need. This fluid, there's an exchange between the interstitial fluids and the CSF. CSF then returns via the arachnoid granulations back into the venous blood flow. So it's pretty nice. Are we okay with this? Do I need to do anything